Here we have the lead acid cell. There's the lead and the lead sulfate, and also we have the lead cathode here. Forms a cell as operates. So this lead sulfate here, it forms as the cell operates. The single cell illustrated usually connected to 6 other series. So we'll take this. The anode is the lead plate. So the lead plate is here, and that's the anode. The cathode is the lead 5 oxide. The lead 5 oxide is this here. The electrolyte is 6 moles per liter, that's a concentration, or you can give it as 6 moles like this, and it's sulfuric acid, as you can see here. Lead sulfate forms as cell operates. So the lead sulfate here, which is in brackets, it forms as the cell operates, and you can see that happening. After many recharge cycles, bridging between the cells ends its useful life. So we know that this is a secondary cell, which means it can be recharged, but when it's going to be recharged, after many of them, the bridging between the cell ends. So we have oxidation here. Oxidation at lead plate. So here we have the lead and the sulfate ions. They would release 2 electrons, forming lead sulfate. And the reduction at the lead oxide cathode, we have the 2 electrons being gained, and we have lead oxide plus the hydrogen ions from the sulfuric acid, and also the sulfate ions from the sulfuric acid gaining electrons to form lead sulfate, which you remember were in brackets before, and water molecules. So we're going to add up these 2 equations. We take these out and we just add them up horizontally, vertically. So you would get lead oxide, 4 ions of hydrogen ions, and 2 sulfate ions, giving us 2 molecules of lead sulfate and 2 water molecules, as you can see there. Now let's move on to the lead acid cell uses. It's mainly used for car batteries, and that's its main use. The advantages is that it's long lasting, so it's years of operation. Because it is a secondary cell, it can be recharged, and it's rechargeable because it's a secondary cell, and it performs well in wide temperature ranges. The size and application means it's relatively portable, but there are some disadvantages. It's expensive. Even though it can be used for a long period of time, it is expensive, and it is heavy as well. Regular maintenance of electrolyte, which is a sulfuric acid. Irreversible changes to the solids bridging between the cell plates cause permanent damage. So this permanent damage is also a disadvantage in the cell.